Control plane also allows you to mix and match any combination of backing services from AWS, GCP, and Azure to a workload, regardless of where that workload runs. So you can have a workload running on prem, and that workload can still consume S3 from AWS, BigQuery from GCP, and maybe Active Directory from Azure. So here I'm going to demonstrate a unique capability of control plane called the Universal Cloud Identity. So when I navigate to my org, I created a global virtual cloud called the Azure GCP Cloud, comprised of only locations from Azure and GCP. These are locations provided by Control Plane, but you can easily include your locations or locations from your customers. So what I want to do next is navigate to an application I wrote in Node. And here I'm simply using the read from DynamoDB function that is using the scan method from the SDK. So when I deploy this application to our Azure GCP cloud, only comprised of Azure and GCP locations, our workload will still be able to consume my two DynamoDB tables that are in my personal AWS account. So what I'm going to say is cplen image build. We'll give it a name, Dynamo version 1. We want to put it in the Taylor org and push it into the private image registry that you get with Control Plane for free. So I'm just containerizing my application at the moment. And what I'll do now is navigate to our console and create an identity. And we'll call this the DynamoDB identity. And here, after connecting my cloud accounts, I can select a specific AWS role or AWS policy. And by the way, you can create as many cloud accounts as you wish. So for my DynamoDB tables, I created two AWS policies for each, a Candy policy and a New York policy. And I'll click create. Now what I'll do is create a workload and we'll leave it as serverless and we'll call this the Dynamo app. Select my container image by pressing Control I on my keyboard. And I will also select the DynamoDB identity. For my firewall, I'll allow all inbound and outbound requests, but you can specify specific CIDR groups in IPv4 or IPv6 and click create. So within a few seconds, we've just deployed a brand new application called the Dynamo app that is currently spinning up in our Azure and GCP locations. So in a moment, these not ready statuses will switch from not ready to ready. And once ready, we'll be able to navigate to one of these individual URLs and see that we would be able to consume my DynamoDB table items, even though I'm running on Azure or GCP. So it looks like Azure East US 2 is up and ready. Let's go ahead and click on it and navigate. So it says, hey, Taylor, specify an item like /candy. When I say /candy, we see Sour Patch, Skittles, and M&Ms. So I'm currently running on Azure East US 2, and yet this workload is able to consume my DynamoDB table items within my AWS account. When I do /New York, it will give me the different neighborhoods in New York. So the cool thing is about Control Plane is that you have this freedom and flexibility to mix and match any combination of backing services from AWS, GCP, or Azure without dealing with credentials or complex IAM policies. So when I navigate back to my application, notice here that I actually commented out the credentials and my access key IDs and my secret access keys. There are no credentials to be found anywhere in my code. My code is completely portable. There is nothing to do with control plane in my code whatsoever. So, behind the scenes, what's happening here, all the clouds essentially copied AWS and how they handle the security token services communication, and by what they call an instance metadata service. And so when Amazon's SDK talks to a well known host name, or IP address that contains some information about the workload. And then, depending on the policies encoded in the target cloud, it knows how to mint a zero trust least privilege ephemeral token derived from the security token services. And so, what Control Plane invented is this universal instance metadata service that knows how to mint such tokens, not just on AWS, but on AWS, GCP, and Azure in such a way that it works universally across any cloud, regardless of where your workload is running.